Hello everyone, today let's solve the problem number 5, longest palindromic substring, right? So we have been given a string s, you can clearly see here, they have clearly mentioned in the question, we have been given a string s, so we have to return the longest palindromic substring, right? So what is a palindromic substring? When I hover over palindromic substring here, this one, this uh, this states here a string is palindromic if it reaches the same forward and backward. They have clearly mentioned here, right? So it has to be means if it reads the same forward and backward, then only it is said to be palindromic, right? A string is said to be palindromic. That's what they have given here. So here let's come to the first example, right? So let's come to the first example. Here we have s equals BA D, right? So here B, either we can consider BAB or ABA, right? Either we can consider BAB or the ABA. This is the longest palindromic substring, because when we reverse the same thing here, BAB, we get the same word, right? So BAB, when we reverse, we get BAB itself. ABA, when we reverse, we get ABA itself. So this is the longest palindromic substring from the BAD. That's what they have mentioned here. ABA is a valid answer as well. BAB also we can return. So both we can return here, BAB or ABA. Both are fine, right? So I hope this is clear. Let's come to the second example here. We have CBBD, right? So BB is the longest palindromic substring. Means if we reverse, we get the same thing here, right? So this is the longest palindromic substring we have mentioned, right? So first, now we know what we need to do, and also we have understood the question as well, right? So we are good with the question, and they have given wonderful examples just for the sake of understanding purpose. So now let's discuss the approach first, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach first. So just give me a second here. So yeah, so the first thing that we need to keep in mind here is we will be going with the dynamic programming approach. Just keep this in mind. We'll be going with the DP, right? So I have considered the same first example that they have given in the question, so that it will be easier to understand. We have already discussed this one. So we have been given string here. The longest palindromic substring here is either we can consider BAB or AB, right? Both are of the length 3, you can clearly see here. So either we can consider BAB or ABA, right? So let's consider BAB. So as they have given the output BAB, let's consider BAB itself, right? So this is fine. So let's move on with the step-by-step execution, right? First, we will iterate towards the individual letters, right? So loop will evaluate the substrings like B, BA, BAB, BABA. So whatever that is there here, B, BA, BAB, BABA, BABA, D, right? So loop will evaluate the substrings like B, BAB, BBA, BAB, BABA, BABA, D, etc. Right? Those are the 5 things. So next, let's move on with the second, this one here. Second step here, BAB satisfy the condition here. So BAB basically satisfy the condition. Here, it satisfies the condition here, where S of L, nothing but the left pointer here. This one is the right pointer here, right? So S of L, S of left pointer equals, we are comparing with the right pointer, and inner substring A is a palindrome. Basically, inner substring A is a palindrome. So BAB. So we'll check from this one, right? This is equivalent to this one. So inner this one is the palindrome. Basically, whole word. This is a palindrome. So this is fine. Substring A is a palindrome. So let's move on with the third step here. Similarly, ABA is valid too, but first occurrence BAB is taken due to the left to right traversal. So we are traversing from left to right, not right to left, right? So first occurrence is BAB rather than this one ABA. So here BAB will be considered first, right? So this one next, while traversal, next traversal will be ABA basically, right? So due to the left to right traversal, the first one we consider is BAB, right? So this is the palindrome which is having the length 3. So either we can consider BAB or ABA. So here in this case, ABA is valid too, but first occurrence BAB is taken due to the left to right traversal, right? So I hope this is clear. So the longest valid path that is found is I mean longest valid substring that is found as BAB with the length 3, right? So BAB with the length 3. So what we will do, we will return the longest valid substring, nothing but in this case the output will be BA, right? So the output that we have got here is BAV, and the output that they have given for the first example is BAB as well. The output that we got is equivalent to the output that they have given for the first example. So our approach works absolutely correct in this case, right? So now we are completely familiar with the approach. We are good to discuss the edge cases, right? So let's discuss the edge cases quickly. So the first edge case is for single character. You can clearly see here. The first edge case is for the single character. So we have only one character. So the output is quite obviously A here. Right? So single character is always a palindrome. Just keep this in mind. We know this one, but still keep this in mind. Single character is always a palindrome. Let's come to the second edge case here. No palindromic substring greater than 1. So we have here no palindromic substring greater than 1. So here no 2-letter palindromes found here. You can clearly see here, right? No 2-letter palindromes is found here. So we will return the first character itself, A, in this case. So A will be the output in this case. Let's move on with the third edge case, two same characters. We have BB here in the input, right? For the input, or S equals BB string, BB we have. So in this case, we have two identical letters that form a valid palindrome, right? So this will be, the output will be quite obviously BB itself. So let's move on with the fourth edge case here, non-contiguous palindromes here. We are speaking of the fourth edge case, non-contiguous palindromes, right? So in this case, we have the string ABCDA, right? So here, no contiguous palindrome longer than one letter or one character is found basically. So we can just return A in this case, right? So we can return A in this case. Let's move on with the final edge case, all same characters. We have 4 A's here, right? A in this case. So entire string is a palindrome here because all the characters are same. So entire string itself is a palindrome. Here we'll return the same thing, 4 A's, right? So these are the 5 edge cases that we need to keep in mind. So the first edge case is for the single character. The first edge case is for the single character. The second edge case is for the no palindromic substring that is greater than 1. So the third edge case is for the two same characters. The fourth edge case is for the non-contiguous palindromes, and the fifth edge case is for the all same characters. So these 5 edge cases that we need to keep in mind. Just keep this in mind. So now we are completely familiar with the edge cases as well as the approach. So now we are completely good to write the code. Let's start writing the. So first what we will do here, let's initialize the length of the string or the string length. So result start index as well as the max palindrome length. We need the max length of the palindrome as well, right? So I'll just go with here int n equals length of the string. This is fine. Start, nothing but the starting index, nothing but we'll initialize this one to 0 as well as max length. So I'll just give max length here. This is fine. Let's initialize this one to initially 1, right? So we are going with the dynamic programming. We have discussed this one earlier. So we are going with a 1D DP array, right? To store the palindromic information for the current R, right? So I'll just go with here of the type boolean. So boolean dp it's new boolean. This is fine. So the first step here, so we have to iterate end index of the substring, right? So we have to iterate through the end index of the substring. So let me quickly write the for loop here. Int r equals 0 here in this case, r less than n, and let's increment the r here. This is fine. So within the for loop, first thing we need to do here is we have to store the diagonal, nothing but previous value for dp of l plus 1 or minus 1. We have already seen this one within the approach. So I'll just give here boolean previous, this one. Let's initialize this one to false. Then again we have to iterate start index backwards, right? We are iterating through the start index backwards. So I can write this one in this way. For int this one, we are editing the start index backwards, right? So I have to give here L equals R, let's consider. So this basically becomes backwards means reverse iteration, L greater than or equal to 0, and backwards we have to decrement the L. This is fine. So within this for loop, basically we have to save the current dp of L, right, before overwriting. So before overwriting, we have to save the current dp, right? Save the current dp of L. So I'll just consider the temporary variable here, because we have to store the dp of L, right? Current dp of L. So that is the reason I'll be making use of the temp variable here, right? So within this, let's write the simple if condition. We have to check whether the palindromic, we have to check for the palindromic condition basically, right? So I'll just go with here if s dot char at L, this one is equal to s dot char at this one R, and this one R minus L less than or equal to 2 here, or previous. Then what we will do here in this case, here in this case we are checking the palindrome, right? So whatever I have written if condition, so within the if condition, if it is then we have to go with dp of L, we will assign this one to true if it is, right? So next step here is we have to update the max length, and we have to start if we have to update the max length every step, right? If we find the this one longer substring in the next step, then we have to keep updating, right? So that's what, again I'll just write one more if condition here. This will be R minus L plus 1. If it is greater than max length, then what we need to do here, let me give start equals L, this is fine. And for updating the max length, I'll just go with max length equals R minus L plus 1, this is fine. So the next step, let me go with else here. Else what I'll do, dp of L, this one will be false. So else it is not a palindrome. If it is a palindrome, then we are going with dp of L equals true, and then we are updating the max length. If this one substring, if the largest substring is found, longest substring is found, then we will keep on updating the max length if the longer palindromic substring is found basically, right? If it is not found, then if the condition itself doesn't this one, what do we call, doesn't match, then we have to assign dp of L to false, right? So if it is not a palindrome, or yeah, if it is not a palindrome basically. So the next step, I'll just come out of this one, and we have to move to the inner substring, right? So I'll just assign previous to temp in this case, right? Simple. So the final step here is we have to return the longest palindrome. Means I'll just go with return dot substring here, s dot substring of start plus max length. Means we are returning the longest palindromic substring here in this case. So I'm going with from substring start plus max length. So every time we are checking for a palindromic substring, and each time we find the palindromic substring, we will be if the longest palindromic substring is found, means if the substring is longer than the previous one, we will update the max length. So basically that is the logic, right? Basically that is the logic. First we will find the palindromic substring, then if we find the palindromic substring that is longer than the previous one, we will update the maximum length. This itself is the logic, basic logic, right? This itself is the logic, right? For this one, for the memorization, we are making use of the dp, right? So I hope this is completely clear. Let me format the code once and let me hit the run button. So I hope this works. Let's see. This has to work. Let's see. Yeah, now we can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So I hope this works for all the test cases. Let's see. So yeah, You can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So here the approach that we went with here is dynamic programming, right? Or we can just yeah, we can just call this one dynamic programming or dynamic programming with space optimization. Nothing but we are making use of 1DDP, right, for the space optimization. So we can just call this one dynamic programming, or you can just say dynamic programming with space optimization. So overall time complexity for this one would be big of n square. So why it is big of n to the power of 2 here, or n square? Because we are checking all the substring from R down to L, right, step by step. So we are making use of the nested loop here. So here you can clearly see this one. I'm speaking of the line number 6 and I'm speaking of line number 8, right? So we are making use of the nested loop in this case. So it will be overall time complexity would be big of n square in this case, right? So what would be the space complexity here? Space complexity would be big of n. Why it is big of n? Just give me a second here. Why it is big of n here? We are only maintaining a single DP of size n. Here, yeah, you can clearly see here line number 4 I'm speaking of, right? So we are making use of only single DP array which is of size n to track the palindromic substrings, right? So overall this one, what do we call, overall space complexity is big of n as, right? So the time complexity and the space complexity for the code that we have written as big of n square and big of n respectively. I hope the complexities are completely clear. I hope whatever the code that we have written is completely clear as well, right? For now, this is it.